reactive. Just substitute. Well, make that little skip here. All right, substitute in the word reactive. Is everybody okay with that? All right, so which group is most reactive on the periodic table? Okay, and then, all right, so did you have anybody in group 1 up there? No, so we don't have anybody in group 1. So then who becomes the next most reactive? So do I have anybody in group 2? Yes. All right, so we got group 2 here and group 2 here. So those two are out because they're not in group 2, right? So, yes. Yes. Now, if I said who's the most non-metallic, you'd be looking for who's the most reactive non-metal. So the most non-metallic would be who? Group. Who's the most reactive non-metals? 17. Yes. ABL, you on a late bus? People on these stupid tardies. You got detention on Monday. I did your tardy thingy during the quiz. All right. So if it said most non-metallic, okay, you do group 17, group 16, group 15. Okay. So what do we do when you have 2 of them in group 2 though? What's the rule if they're in the same group or they're both metals? Whichever one is further down. So that's why we pick CA. Is everybody okay with that? Yes? Amaja, yes? You looked at me kind of odd. I mean, I am odd, but is the question okay? Okay. All right. So number 2 has 2 questions. We have ionization energy and electronegativity. They're the same trend except for the glitch, right? So which one goes all the way across to group 18? What did you say? Okay. All right. All the way across to group 18 is ionization energy. All right. All the way over to group 17 is which one? Electronegativity. So we stop at group 17 with fluorine. That's electronegativity. So group 18 is going to be which one? Neon. So ionization energy will be neon. And electronegativity will be which one? Cl.
I thought you meant like which one has the highest ionization and electronegativity.
Yeah,
like together. So I didn't do 2 parts. I just put Cl. So I was like,
that's what I did.
You.
Oh, I understand what you're saying. I was like, oh, no, that's not what I meant. I just meant which one has the highest ionization energy, and then which one has the highest electronegativity. I was just trying to fit it in the small space, and the print wasn't too small. All right. What are the 3 types of bonds? Okay. How do we tell the difference between ionic and covalent?
Ionic is metal plus non-metal.
Good. Covalent?
Is non-metal plus non-metal.
Okay. Can you do it the other way too? Ionic would be between the range of 4 to 1.7. Covalent would be? Yes. Okay. Now, 4 to 1.7, and covalent would be 1.7 to 0.
You said that it's not going to be on the quiz, right?
And it's not on the quiz. Your quiz stops here. Okay. Monday's quiz will be below the line.
You said we don't have no quiz on that.
I did not.
Yes, you did.
I lied.
You did. No, you can't.
I lie all the
Teachers are
time.
not supposed to lie. To their self.
I lie all the time. Particularly if it benefits me. All right. So, number 5. What kind of bond do we have in NABR? Ionic. It's a metal and non-metal. SO2. Covalence. 2 non-metals. Fe. All right. HBr. And ASI5. And N2. Fabulous. Questions?
Wait, so that can't be metallic because
What?
it's not a metal.
Correct. Yes.
Wait, going back to number 4. What if it falls like on 1.7?
If it fell on 1.7, I would take either ionic or covalent. I try hard not to get them on the line, but if it did, I would take either answer. I would not hold that against you. Anybody else? Did y'all hear what Alex asked?
Yeah.
He asked if it landed on the 1.7, and I said I would not hold it against you if you said either answer. All right, what else in the opening is bothering you? All right, do we want to talk about the homework? I know Caroline got the answers, so she had the right answers to study. Do we need to talk about the answers or go over the questions? Okay, I don't mind. All right, so question 1. Which of those metals is least reactive? Oh, y'all need a moment to get your paper out?
Yes. Is it worksheet number 4?
Yes, it's worksheet number 4.
Okay. B.
All right, I hear B. Do we agree with B?
Yeah.
You should. B is the right answer. Okay. Cl and D is out because it's a non-metal. So you have 3 metals to pick from. And A and C are both in group 2, but lead is in the P block. So the P block is less reactive. So it's B. All right. Which non-metal is less reactive in 2? C is correct. All right. And number 3, which element has the smallest ionization energy?
C.
C, potassium is correct. Which atom or ion is the smallest out of those 3?
C.
No.
B.
B.
Oh, I forgot. Don't judge me.
Okay, I won't.
Wait, what?
It's a judgment-free zone today.
I had a brain fart.
It's okay.
Can you explain 2?
I can. Number 3 is C. Number 4 was B.
Can you explain that?
And number 3, you're doing ionization energy.
2.
So you said 2 or 3?
2.
Okay, 2. It says non-metal, right? So you have F is in group 17. You have O is in group 16. You have N is in group 15. And then you have, what else? We have CS. CS is a metal, so that should be out of the running. Okay? So we know this is most reactive. And we know the trend is group 17 is more reactive than group 16 is more reactive than group 15, right? And the question said which one is least, right? So who would be least reactive? Group 15, so that's why the answer was nitrogen. Yes? No? Question? Ask. I'll answer. Or I'll try. You sure? All right, where are we at?
Can we do 3?
Yeah. All right, so Lolly wants to do 3. So 3 has argon over here, phosphorus here, Na here, because they're all in the same period, and then CS down here. So the trend for ionization energy. Ionization energy does what as we go this way, and what as we go this way. Okay, I only know one. And I told him this one, I was teaching this. The only one I know is atomic radius. Okay? It's the only one I know in my head. Atomic radius decreases, increases. It's the only one I know. The other 2 are the opposite. Okay? So, if I know the other 2 are the opposite, they increase, they decrease.
When you say other 2, which one do you mean?
Ionization energy and electronegativity.
And so they're the same?
Mm-hmm. Yep. So, the question said which one is the smallest ionization energy. So, out of these, which one is the smallest ionization energy? If this increases, that's got to be bigger, right? If it decreases, that's got to be smaller. So, CS has to be the smallest.
Wait, what are we on?
3. Lolly wanted me to go back and explain 3.
Wait, but we said the answer was K.
Oh, sorry, I grabbed the element out of a different question.
Yeah.
Let me just put K there. Whoops. K's the answer. I just grabbed an element out of a different question. I had the other 3 right. All right.
We're on 5 now.
Everybody good with the questions out of 1 through 4? All right, so number 5 should be B. And 6 should be what?
C.
Yep. Questions about 5 or 6? How are you today? They're not liking trends.
Huh?
They're not liking the periodic table and trends. We're going to draw Lewis structures today, though.
Oh, that was fun.
You like those? Yeah. All right. 7 was or is B. 8. I got y'all again with that stupid gas.
Yeah, see, I didn't even pay attention to that explanation. Which is probably gonna kill
I told you I didn't put one like that on the quiz. 8 is D. Nitrogen's a gas. I was playing with y'all again because I can. There's no perks in this job. I got to pick on teenagers when I can. All right? There's not one like that on the quiz, I promise. There's not one like that on the test either. All right? Number 9. I heard it. C. 10. C. 11. D. 12. C. Number 9 is C as in cat. The only one that was hinky was number 8, and I promise I didn't do that on the quiz or the test. It's not, but it's like this in that there are 4 choices, and you just have to tell me which one of the 4 choices.
So is that
Can.
a warm-up thing?
Yes. It's more like the warm-up where there are 4 choices, and you just tell me which one. Remember which one? Yeah. All right, so it says melting point, right? So what's the trend for melting point? D block is greater than, which is greater than, which is greater than. Yeah. So when you look at them, you can tell me SR is where? Where does SR fit? It's in group 2. And K is? And AG? And AL. So who would have the greatest melting point? That's why it's AG. All right. What else?
The trend for the reactive and mixed reactive is just that, but it's
Opposite. Yep.
what?
She said about reactivity. It was that trend, but it was flipped. So this would be most, and that would be least. Anything else?
No. Yes. On number 8, the reason why it couldn't be that answer is because of the gas.
Yeah. Nitrogen is just a gas. Gases are always less dense than a metal. I told you. I didn't do that to you on the quiz. So if you had picked lithium on the quiz, you'd have been right.
I mean, we could have like 10 questions of that. We just figure gas in time.
I didn't do that either.
So, atomic radius is when it goes down, it's getting bigger.
When it goes down, it's getting bigger. Yes. That's okay. Just know that one, and then the other ones will be different. All right? Now, do you want a periodic table you can write on, or do you want to use your orange one? Then get your orange one out. All right? And you need something to write with. Yeah, what time is it? Quarter till? By 9, you should be done. It's 10 little questions.
Caroline.
I need time to think.
You need to learn how to work within time constraints.
But I can't.
The test is 78 questions,
But I can't.
and you only have an hour and a half.
You
You need to learn to work faster. No. Now, you can see that each question has 4 answer choices except number 9. There are what? 6 choices there with 2 questions. I'm not saying that the answer cannot be used twice on that question. Okay?
What's that again?
If you look at number 9, there are 6 choices and there's 2 questions. I'm not saying that the answer cannot be used twice. Okay? I don't even remember what the question says. But before somebody asks me that, ABL and his target. Yeah, go ahead. How many of you are still working? I just got 2. Not sure the one wanting bonus points if you were done.
That was a thing? 2 or 3. 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 2 or 3.
No. I just put you in the back. I don't suppose your ride gonna leave us.
We got a flood tire this morning.
Gotta hate when that happens.
We tried to pump it up.
Don't do that, bro.
Look, I ain't gonna mess up, so.
Easy.
He said, like, I can have something. So we basically run around, so.
You know you're gonna detention Monday, right?
Yeah.
Monday, done. Mount, I imagine. Hey, give it a guess. Mimi, mango. Wow, Almaj is kicking her last answer. The rest of y'all paddle forward.
Okay.
Just a little bit. Without you. No. Is he?
Just don't second guess yourself. You could be the worst thing.
You shouldn't.
What was the first answer you got written down? Put it back. Whatever your first answer was, put it back. Where's yours at? Listen, no.
You didn't even cut your hair close. Really?
All right, find your notes. We're going back to bonding. I know it's a hot topic.
Will there ever be a day we don't take numbers?
Will there ever be a day you don't take notes? Yeah, on test days. Exam day.
I mean, where we don't take notes, so we don't take a test or an exam.
Lab days.
And we don't take notes.
Will there ever be a free day?
Yes.
No. That's basically what you're asking. The answer is no.
Is this continuation of our notes?
Yes.
It's cold and.
It's warm in here. Go hang out in Miss Rector's room. It's like an ice box.
It is, but I don't know.
Yeah.
Why is the hallway so hot and then you get the blue ones?
I don't know. It's warmer in our hallway. Miss Wicker and I hang out there in second period to warm up.
Miss Wicker's room is cold.
Hers is warmer than mine. Go hang out in Miss Rector's room. That's like an ice box.
It feel like.
Well, sometimes we open the doors up to let Miss Rector have a little heat. So we suck out some of the heat. It's really bad over there, so we feel bad for them. We don't know, but we're afraid to complain for fear they'll turn us into a song. The last time we complained, we all needed shorts to teach. So we're a little fearful.
I like pink.
You know, us fat people can't be teaching in our underwear. Now, yesterday we wrote down this chart, okay? So we said that in order to find bond type, we would subtract some electronegativities to determine the type of bond, thereby habits.
Yeah.
All right. And you've got out your electronegativity table. Before I start talking about it, everybody's going, where is she getting these numbers? That would be the white table I gave you yesterday. You could just use your electronegativity table. It's got the elements on it. I think you'll be fine with it.
You said we will have this on the exam.
You will not have that on the exam. I told you, if they want you to use that, those numbers will be part of the test question. Okay? Then they won't expect you to use it. Okay? They will either put them in the test question or they will not give it to you. You will just use the periodic table. Okay? One or the other. All right. So, what does it mean to be a polar covalent bond? Since we have this on this chart that we're going to use today, we need to know what it means to be polar covalent before you guys think I'm talking about polar bears all day and it's cold. Now, because I'm sure some of you probably thought I was talking about that yesterday. Now, a polar covalent bond is a bond where electrons are not shared equally. Okay? The electrons are not shared equally.
So is it like polarization polar or like?
Two different things. All right, so if we have hydrogen and chlorine like we had the other day, and we have two electrons being shared between the hydrogen and the chlorine, we said hydrogen had how many electrons in the outer shell? Do you remember? What group is it in? So it has one electron. How many electrons would chlorine have in its outer shell? 7. Because it's in group 17. Now, based on what we did before, we said that everybody in group 1 wants to do what with its electron? That's right, it wants to lose. And everybody in group 17 wants to do what with its electrons? Gain. So if you know that group 17 wants to gain those electrons and group 1 wants to give those electrons, do you think those electrons are there being shared equally if group 1 wants to push them away and group 17 wants to gain the electrons? No. Okay? So these electrons are being pulled towards chlorine. Okay? So the electrons are pulled towards chlorine. So they are not shared equally. Okay? That's called a polar covalent bond. So any bond where the electrons are not shared equally, we call that polar covalent. Now, the flip side of that is called a what kind of bond? A non-polar covalent bond. All right? So a non-polar covalent bond is a bond where the electrons are shared equally. A bond where the electrons are shared equally. So, electrons are shared equally. So if we look at like one of our diatomic molecules, Cl2, how many electrons, again, does chlorine have in its outer shell? Okay. Now, would either of these two chlorines pull more than the other on those electrons? No. This would be like I've cloned Annette. Okay, imagine two of her. Would either Annette, I know your mother's frightened for that, okay? Would either Annette pull harder on the rope than the other Annette? No, okay? So these electrons are pulled equally between the two chlorines. And because they're shared equally, they're called a nonpolar covalent bond. Now, you understand the difference? They do not have to be the same element, okay? So if you had, I think pH3 is one that we could have. All right, I'm thinking I have the right elements in my head. pH3, if you look up phosphorus, what's its number?
2.1.
Hydrogen is?
2.1.
You get 0. Phosphorus and hydrogen are going to pull equally on their electrons. They would also be a nonpolar covalent bond. Okay, what did I say yesterday about the subscripts? Well, we use the subscripts. No, we just look up the P, we just look up the H, we subtract, and we get 0.
So it just has to be two of the same number?
Uh-huh. Now, it doesn't even have to be identical. It just has to be less than what number when we subtract? Less than 0.3. Okay? Remember. Now, answering Alex's question from a minute ago, when it lands on 0.3, I put it in polar covalent. Okay? This one, I tend to let you put either direction. But once you hit 0.3, I put it in polar covalent.
Okay.
Because you really want that difference to be very small to make it non-polar covalent. Okay? 0, 0.1, 0.2, that's non-polar covalent. Once you start to get a bigger difference, I lump it into polar covalent.
Wait, so why do we need to know that if we can?
Because you're not always going to have the chart.
No, that.
What?
Scale, 4.0, 1.7, 0.3. Like, why would we have to subtract and figure out if they're the same? Figure out if they're non-polar or polar if we just have the difference in what we use.
Because you may not have the scale. So you need to know the definitions in case they ask you something about the difference in sharing. You may not see this at all on the exam. You may not have that scale. Okay? You may not get anything with those numbers in the test question. Okay? Remember, I've not seen the test in at least 7 years. No idea what you'll see on that exam. I have 2 released versions of the test. The last one I got was maybe 2015 and it only has 14 questions on it. Yeah. So I don't know. It's a crapshoot. I teach what they tell me to teach and pray for the best. Okay, so if we go back to what, I need to put one on here that I added. I think it was chromium.
Yes.
I put CR, it's at the bottom. I'll just write it at the top. All right, go back and do these same things. You left space yesterday, but use your electronegativity scale now. Yes,
You have Travis running this.
I do.
Okay, I just put work in your box.
He did it.
Just gonna say I put work in your box.
Okay. Okay. The answer to the next question was. There's no way he did that right. Or did it when I left. If you will subtract the numbers and write them down, please. There's something else we need to do with the answers you have here. It will make it so much easier if you have the numbers when you subtract written down, and you'll see why in a moment. Okay? You don't have to actually write the actual numbers down. Just write the answer when you subtract down. No, as long as you write like 2.1, you're fine. Okay? The 2.1 is all you need. So when you subtract like NaNCl and you get 2.1, as long as you write the 2.1, you're fine. You don't have to write 0.9 minus 3.0 equals 2.1. That you don't have to write.
So what if you only have one number?
Which one only has one number?
CR.
That's right, because metals are not on the scale, right? So once you know they're a metallic bond, are you going to use the scale?
No.
No. Remember, metallic bonds are never on the scale. Can we talk about that yesterday?
No.
I was forced you to ask that question.
She asked something about, I don't remember what I asked.
So for this one, do we take the chlorine and the chlorine?
Yes, that we talked about too. Okay, I remember we talked about this. We have chlorine written as chlorine. We don't write it this way, right? We just write Cl2, but it's technically chlorine. So you subtract a chlorine minus a chlorine. But remind me in a moment and we'll talk about the CR. Since we have forgotten that we talked about it at the end of class.
Did you want, you said, okay, never mind. Never mind. Oh, okay. Question about this is a really good question. Notice that two of the things that we did on there, two of them were going to be wrong, right?
Like what we did yesterday, so it'll be wrong.
The way that we labeled.
Yes, there's two of them that should be wrong.
Okay.
Yes, you should find two that are wrong.
Did you do the positive?
Yes, just a positive difference. All right, got it?
No.
You said no?
No.
You struggling with something else?
No, just hold on.
And what we got? Okay, so CR, the top one is up there. All right? What do you know about CR? It's a metal. When you see just a metal, you don't look up the numbers, you don't subtract, you just label it as a metallic bond. If you look up the number for a metal, what number did you find for CR? What? Yeah, you're either going to be right above 1.7 in this range or right below in this range. So you're either going to get ionic or you're going to get polar covalent. Either answer is going to be wrong, okay? So when you're looking at this, once you've identified that it's a metal, you just want to write that it's a metallic bond. Do not look it up and try to put it on that scale because metallic bonds don't fit on the scale. There's no place for them, okay? Now, everything else that's up here fits on the scale. So, NaCl, you got 2.1, so you said it was what? Okay. Did it agree with what we did yesterday?
Yes.
Yes. All right, PCl5, when you subtracted it, you got what number?
0.9.
0.9, and so you got polar covalent. Did it agree?
Yeah.
Okay. CaI2, you got what? And you got polar covalent. Did it agree? No. Yesterday, you predicted that that was an ionic bond because it was a metal and a non-metal. Now, again, if they don't give you the electronegativity numbers, the state is going to expect you to say metal, non-metal, it's an ionic bond. That answer would be correct on the state test. If they give you the question with the electronegativity numbers in it, they're going to expect you to subtract, get 1.5, and they're going to expect you to say, oh, that's a polar covalent bond. Do you understand the difference? Okay. If they don't provide the numbers, you just go metal, non-metal. Okay? I have no idea which one they'll give you on the test. Yes, ma'am.
So you wouldn't like use the 5, the subscript?
No, you just look up the elements, subtract, and get the positive difference. The subscripts mean nothing.
Question,
Yes.
how often, like, is a question like that is on DJ?
All I get is a score. Now, it's taken until today to get any kind of feedback on the exam. All I get on exam day is out of the 3 types of content I taught, what percentage y'all got. Like, y'all got 30% of the questions right. That's all I get. Today, I know how much growth you got. That's it. That's all I know. Nothing is specific by question or by topic. For example, all I get is the periodic table and bonding, 30%. It doesn't tell me anything more than that.
So what you're saying is when people don't do good on
I don't know anything.
it. But if you know the percent of that,
I know that my growth is good, and I know that my scores are good. Short of that, I know nothing.
Is it curved?
The exam, the chemistry exam has the smallest curve of any of them I've seen.
But does it normally curve?
It is curved, yes. The better you score, the smaller the curve also. You will get a very small curve. The worse you score, the higher the curve. Just saying.
so what you're saying is,
We should
I
all
should
score
attempt
low.
to,
Huh?
I should attempt, well,
If you make a 30, you'll get a higher curve.
What?
30 will get curved to in the 50s usually.
I'm gonna.
No, I do that one. That's still not good.
That's a lot. I'm gonna try to.
I'm gonna try to.
That's a good goal. All right. So, HF, what'd you get there? Okay, so you got 1.9 or is it 2.0?
1.9.
1.9, so you got ionic. Now, we had predicted this one yesterday would be what? Covalent. All right, CH4, you got what?
0.4.
0.4? So you just said this one was polar covalent? All right, and this is the one Annette asked about. When you have Cl2, we don't write ClCl, but we talked about this yesterday. It is ClCl. So when you go to subtract, you say 3.0 minus 3.0, so you get what? 0. A lot of people write 3.0 when they see Cl2, but it's not 3.0. You're subtracting these two. So you get 0, so its type of bond is what? Non-polar covalent.
So just remember that we always have to subtract.
If it's diatomic that way, yes.
But like all these, you're gonna have to subtract unless it's metallic.
Unless it's metallic, yes. All right, so the last thing you have to do with these, did I put it up here? Yes. Rank the bonds in order of increasing ionic character. This is why I wanted you to write the numbers down.
greatest, leadest in the scale?
Yes.
Leadest? Oh my god.
All right. So here's our guy. I knew what you meant. I knew what you meant. I do that kind of stuff all the time, so I'm very forgiving of that. Remember, it's a judgment-free zone, isn't it, Diamond?
Right.
Remember, you made a mistake earlier. It's a judgment-free zone today.
Just today.
Yeah.
What do you do with the
So when we look at the scale, where on the scale would we have the increasing ionic character? If we go from 4 to 0, where is the greatest ionic character?
It's in the ionic range.
Okay, so let's just go 4 or 0. Let's make it easier. That's right. So this will be the greatest ionic character. So we need to go this way. That will be increasing ionic character. If we go towards 4. Now, well, I always ask the question that way. Nope. Just because you know there's got to be a perk in this job. No, but tormenting teenagers is a great perk. All right. Sort of like going home telling my son to pick his room up just so he can bristle up and get pissed at me in the afternoon. All right. So when I look at the chart, what if I said greatest covalent character? Where's the greatest covalent character? Is it 0? So I would do it this way. So now we should be able to answer the question. Huh? Believe it matter. You're going to be what? You just put them in order by number. We left the numbers in our assignment. That's why I said make sure you write the numbers down. And that even said, Ms. Wald, we need to write the numbers down. And I said, yes, because it would make life easier for us, right? Really, dude?
Yes.
Okay.
It's a lot of work.
Okay, now I can't fix that.
What do the arrows mean?
That means you put them in order going that direction. Yes,
You want to start the formula or the number?
the formula. All right, so the question said, put these in order according to increasing ionic character. Okay? So, least ionic to most ionic. So who is the least ionic? The one that's closest to what?
0.
0. And we're going towards the most ionic, which would be 4. Now, who doesn't get included at all? That's right, because he's not on the scale. So chromium gets jumped. Everybody with me on chromium's getting left out. He doesn't get included. Now, we're just going to make a list.
Wait, okay.
Oh, so it's like that, maybe like greatest.
Yeah, it's like math. Greatest to least. Least. Least.
But we have to do this so any quizzes.
We have greatest on the right.
But money. Yeah.
I'm going to go left to right when I make my list.
Because that's what was messing up.
Yeah, I'm just going to go left to right when I make my list.
I'm telling you, that's what messed me up.
Oh, sorry.
Greatest on the left. And I'm like,
Oh, no, I'm just going to make my list. I just wrote the scale the way the scale always looked.
Like, I don't understand that either. Why would it be 0 be on the right? Like, if it was -4, I get that. But it's positive. So why would it not be flipped?
Ask the scientist who wrote it. I don't know.
You should, like.
I was not there when they created the scale, okay? It's just the way it's always written in the textbooks. Okay. So, if we go back, who is the least ionic up here?
CL2.
Cl2. So, Cl2 is first. Who's next?
CH4.
CH4. All right, next.
PCL5.
Okay, PCl5. Oops, wrong way. No, I did it the right way. PCl5 and then CAI2. Next. HF. And ACL. Now, all we did was go from 0 to what? 2.1. So that was least ionic to most ionic.
What? I thought it was the other way.
See?
I just saw that.
What?
I didn't see it.
The direction of this is just the way the scale is written. You're going from the smallest number to what? The biggest number. Because you're going from least ionic to most ionic. Smallest number to biggest number. So chlorine is the smallest number you had, and you're going to the biggest number. I'm always going to write them in a list from left to right. Okay? So even if I did this and I was doing increasing covalent, I'm going from 4 to 0. I'm still going to go left to right when I write my list. Okay? But I'm going to go from the biggest number to the smallest number. Okay?
Look at his notes.
Huh?
Look at his notes. Can we go home?
No.
I don't want to be here.
I don't want to be here either, but we're stuck like rats on a sinking ship.
I mean, we may be able to finish it, but
All right.
what? Okay, excuse me, Angel?
No, Angel.
All right.
This point's not gonna come from. That's just me. How do I do taxes? I didn't do like I missed the meeting. I was like.
All right. Do that very quickly. I want to at least get the vocabulary done today, so Monday we're just drawing Lewis structures.
We are drawing them today.
We're not going to get to them, but we can at least get that stupid vocabulary done, so Monday we're just
Why do
drawing.
we have to do vocabulary?
Lewis isn't here today.
Why?
Because I don't want to do it Monday.
No, but why do we need to?
Why do we need to?
We.
Because you're not going to know what I'm talking about Monday and Tuesday if we don't.
I still don't know what you're talking
And
about.
believe it or not, in the released questions that they put out there at the end of the year that we'll use for review, the vocabulary that I'm going to talk about here in the next 25 minutes are probably in 3 of the 14 released questions.
They only.
I have no idea why.
Thank you.
Oh my God, you know. I was going to do
I'm right. They have the, Caroline, the college best sport news reading at this time. We went there Sunday. Yeah.
Well, you'll be thrilled next year then if the city schools goes to the county school calendar.
What are they doing?
2 weeks break.
Yeah.
Well, you
Oh, yes.
If we follow their calendar. Don't get excited
What
yet.
these people did
I hope we do.
We always go back to
exam
school January
before
3rd.
versus like normal.
They decided to change it. Like, they've
Next
only
year we
done
would
that-
go back on like the 6th.
They've only done that one other year, and I think it was 7th grade, and it sucks.
You only get 1 week to let you get out of school.
What is the calendar like? We're so confused.
We got a week and a half this year. It sucks.
My mom will get mad at me. Well, that's included. She doesn't like me. That other half. Yeah, like, my mom's literally like. Doesn't feel like you doing here. Like, I'm sorry that I live in this house. Like, I'm telling you, my parents do not like you. Like, what are you doing here? Aren't you supposed to be at school? That one day that I slept in before the pre-ACT, I wasn't going to go to the exam. She was like, why are you still here? And I was like, I have an exam today. I'm not, I just gotta put some clothes on. And she was like, go to the bus. I will be there in like 2 minutes. Like, did you probably do? Yes. I bet she loves that.
All right, we got an answer?
I know. So sorry.
Hurry up.
Try.
I am rushing you.
Yeah, my parents don't like it. I did the guessing after I heard that's what I did.
This is on your quiz Monday.
Wait, this, like, ranking stuff in order?
Yep. Nope. Plus the camera if you ain't got there.
That's on the quiz too?
Can the quiz be multiple choice?
Quiz is not multiple choice, it's all free response.
Like, this is the bus stop. Or is it just
What'd you say?
I hate gold.
Tuesday is a no. No, Monday is a yes, Tuesday is a no. Because the next quiz will be after break, and it will be Lewis structures, determining geometry and determining polarity.
I keep forgetting about it. We got a name. Yeah, and I'm so sick. I'm already, it's gonna be so, I know, right?
All right, so what number did you come up with for CO2?
One.
All right, so it was what kind of bond? Polar covalent. Now, can you just say polar
No.
before we do this on the quiz Monday?
Yeah.
Can we just say polar?
No.
No. What were the 3 bond types? Ionic, covalent, metallic. Did I call one of those bond types polar? No. You have to call it polar covalent. You cannot call it polar.
Wait,
All right.
What does it do to them?
Polar makes it unshared or makes it shared unequally.
Oh,
Okay? But you have to say covalent.
All
right. Yeah, you can write PC. That's fine. All right. CSF was what difference? 3.3. So that's what? All right. MN is what? SiCl4 is? So that is 2.2 seems high. 1.2 sounds better. Polar covalent and Br? 0. So non-polar covalent. All right. I said rank in order of increasing covalent character. So increasing covalent character will be going from what number to what number? All right. So 4 to 0. All right. So who's the biggest up here? So CSF. Who's next? SiCl4. To who's next? And who's last? And who do we leave out? MN. Everybody got it?
Don't put the metallic in.
Do not put the metallic in it. This one's out. It does not go on the scale. Okay? All right. What is a molecule?
Is this the vocabulary?
Yep. 2 or more atoms covalently bonded.
Just Tyler. ties on to those we just took.
Hmm?
I said, this ties on to those we just took.
Oh yeah, all this still is in bonding.
Wait, but why does it say covalent?
Because that's the definition for a molecule.
But ionic things are molecules too.
No, they don't.
Who are they?
Formula units.
But I thought molecules and formula units were the same thing on a chart.
They are in terms of calculating them, not for vocabulary.
I don't know.
You can, but it's not necessary. You can just look and figure out that. Now, for the purposes of the remainder of the day, this is an exercise in vocabulary that's going to drive Caroline nuts, apparently. All right, a molecule is two or more atoms that are covalently bonded. All right, now, covalently. What does it mean to be covalent? You have to be nonmetals. So when we talk about a molecule, you have to be a non-metal. So, if I ask which of the following are molecules, out of my list here, are there things that are not molecules?
Yeah.
Which? That's it. Those are not molecules. The other things are molecules. So, those things cannot be referred to as molecules. They could be formula units. They can be compounds. They're not molecules. So if I was to say to you which of the following are molecules, those would have to go. Now, everybody got it?
Yeah.
All right. So what is a diatomic molecule? We can talk about examples in a second. What is it defined as?
Something with the subscript two.
With the same name.
Okay. Two atoms covalently bonded. Do they have to be identical? No. Okay.
So do molecules have to be identical?
Mm-mm.
So what's the difference between this and a molecule?
In order to be a molecule, you have to be what? You have to be covalently bonded. The number of atoms does not matter. How many atoms are here? Let me change colors. How many atoms are here?
3.
Do we know how we got 3?
1.
1 plus 2 is 3. How many are here?
4.
How many are here?
2.
How many are here?
5. Okay.
Okay.
So it's because we have a little 2 at the bottom of the diagram.
Okay. They're all covalently bonded. The number of atoms is irrelevant. Okay. To be diatomic, you can only have how many? 2. And they still have to be what?
Okay,
Covalent.
so are you gonna use the same one from the one before this?
Probably not, because I won't remember what I had on the board.
Great, okay, so out of that list, the only one that would have been a diatomic molecule would have been CO.
Yeah, probably.
Because it has 2. Well, what about Ki?
Ki is not a molecule.
Oh, yeah. Is that a big O or a little O?
That's a big O. All right, so if you have any of those, would you label any of those as being, first of all, covalently bonded? And then secondly, as being, I need a little more space there. As being diatomic molecules. Because you have to ask yourself both questions. All right? In order to be a diatomic molecule, the first thing you have to know is, are they covalently bonded? Because if they're not covalently bonded, can they be diatomic molecules? No. Because most people, I find, rush to, oh yeah, they're diatomic because they have two. But the first thing you have to say is, are they diatomic? Because if they're not covalently bonded, they can't be diatomic molecules. So, who fits both criteria up there? All right, I hear CO and I hear Cl2. Hold on, let me change colors. All right, so I hear Cl2 and I hear CO. Do we agree with those two first?
Yeah.
All right, you should. They're both diatomics. All right, two chlorines are both nonmetals, and there's two of them. Carbon and oxygen are both nonmetals, and there's one C and there's one O, so there's two atoms. Both of those are correct. All right, is there anybody else up there who fits HBr? All right, HBr is both nonmetals, and there's only two of them. All right, anybody else? No. Okay, NaI is ionic. So even though it's diatomic, it's ionic. That's why it's out. KCl is ionic. So it's out. This one has 5 atoms. That's why it's out. This one only had 1. That's why it's out. Is everybody okay with why the other ones were disqualified? What? The definition of diatomic is you can only have how many? 2. Okay? If we weren't talking about diatomic, it would be okay to have 5. But that one's a metal, so it can't be there, first of all, but it only has 1, so that's why it was disqualified. Okay? Because we were talking about diatomic. Everybody okay with that? All right. So from now through the end of class Tuesday, we are only going to talk about covalent bonding. So from now through Tuesday, I want you to think the word shared electrons. Okay? When we come back from Thanksgiving, we'll talk about electrons that are lost or gained. But from now through Thanksgiving, we're talking shared electrons. Okay? Because everything we're going to do tomorrow with Lewis structures and all those geometries and polarities we're going to do on Tuesday are all about shared electrons. Okay?
You said tomorrow. Yeah.
Oh, Monday. Whatever. The next day we're here. Whatever that is. Whatever that is. Okay? Now, the next day we're here. There are 3 types of covalent bonds that we're going to learn to draw. Okay? We're going to learn to draw a single bond, a double bond, and a triple bond. The single bond will be y'all's favorite because it's the easiest. And after we learn to draw it tomorrow, y'all going to be going, oh, this is easy, Miss Wall. I like these. And everybody's going to be good until I throw in the double and triple bonds. Then you're going to be going, oh. All right. And then some of you are going to still be going, I like this. This is easy. Now, a single bond. What is a single bond? All right. It's a bond that shares a pair of electrons. Now, what's a pair?
2.
2. Okay? So, if I ask this in multiple choice format, please remember it's not sharing one electron. A bond is always two electrons, never a single electron.
So it's the only one that can have that one.
Huh?
It's the only one that can have that one.
Can have double or triple too. Okay. All right, a double bond will share two pairs of electrons. So that will be 4 electrons. And then the last one shares 3 pairs of electrons, which will be 6 electrons. Okay? Everybody caught up? Now, the last thing we're going to do and finish with today, and we might not quite finish it, we might have to finish it Monday, are bond length and bond energy. Okay, and then we'll be ready to do Lewis. And Lewis is not bad. I think most of y'all will like them. Remember dot diagrams?
Yes.
Lewis is the same guy who did dot diagrams. We're just going to do it for whole molecules now instead of just one element. All right, we good? You mean wait? Where are we at? All right. I'm waiting. All right. Let's do bond energy. It's shorter. All right, bond energy is the energy needed to break a bond.
How big is the section?
Not very big. I can probably do bond energy on 5 lines. I'll say bond length for Monday. All right, so do you know what that is if I draw it that way? Annette's got it. All right, that's a single bond, a double bond, and a triple bond. Okay? So this is a carbon, single bonded to a carbon double bonded to a carbon, and a carbon triple bonded to a carbon. Okay? Now, it's stupid. It's the way we shorthand it and abbreviate it. All right, so this would be a triple bond between a carbon and a nitrogen. All right, so which one of these do you think would be the strongest and would require the most energy to break? All right, the triple bond is the strongest, and it will require the most energy to break. All right, the single bond here is the weakest.
Oh, no.
All right, and it requires the least amount of energy to break. Right? Now, we will do bond length on Monday, so I have time to talk homework.
I vote we shouldn't have homework. I vote you should just let us. We should have.
How about it's only a half a page?
That's half a page.
Too much.
That's a full page.
You know, you
I will grade it completely up to you. Don't do it. You have a quiz on Monday. It doesn't matter to me if you do it at all. Quiz is easy, I think. I think all the quizzes are easy.
Yeah, if it's easy, I think we should get a grade.
So if we do it,
Can we get a grade for it?
like 5 points extra credit on my quiz.
Yes,
Is
yeah. What about that? At least one, what about two? What about that? How about 5 points?